Coming up on today's podcast.
Why is Tesla not able to do that yet? Well, Tesla's approach is, you could euphemistically say, it's more ambitious, which is that Waymo's cars have LiDAR, which is like firing a laser beam at objects, measuring the time it takes to return. It's basically laser radar, and it gives you a genuine 3D spatial volumetric model of your surroundings, whereas Teslas rely essentially on vision. The point is that the metaverse will, when it arrives, it will not arrive via the pathway that most people expect it will, which is like video games and sort of clunky virtual reality headsets. It will arrive in segments like slices of a pie, and we already have some of those segments. We have our smartphones, we have our computer screens, we have digital signage in public, and every facet of digital information is part of the metaverse, and they will eventually all merge, and then we'll have effectively a digital layer on top of our analog existence.
Hello and welcome to How to Understand Today, your regular sojourn into the world of tech as we dissect where we're going, where we've been, and what the implications are for our everyday lives. I'm Simon Wyndham.
I'm Dave Shapton.
I'm Phil Rhodes.
And today there's a few topics that warrant our attention, not least the news that AI has finally passed the Turing Test, and the question of whether artificial intelligence is something we can truly control. But to begin with, let's talk about cars. Anyone who grew up in the 80s with Knight Rider as one of their favourite TV shows will have dreamed of having a self-driving car, a dream that will have only grown in desire once the idea of going out to the pub was discovered. But despite many prototype cars, along with driverless taxis showing that statistically they are potentially safer than human-driven vehicles, headlines about mishaps still plague the technology. After a recent test showed that one particular make of car with self-driving ability couldn't distinguish between a real road and a picture of one painted onto a wall, and a robo-taxi in Los Angeles decided to drive its occupant repeatedly round in circles in the car park while he was powerless to stop it, it's fair to say that the public at large may need a lot of convincing before the technology becomes truly saleable to the masses. And that's without considering the very complex insurance issue. So, Dave, how do you see the driverless car landscape panning out? And with public skepticism constantly a spectre hanging over the technology, can we say with any certainty that fully autonomous cars are truly the future?
Well, word certainty is the biggest issue here. And I think with reasonable certainty, I can say that, yes, we absolutely will have driverless cars. And I can say with absolute certainty that we already do. It's just that they're not good enough. And the biggest question is, what do we mean by good enough? You'd be tempted to say, well, they mustn't cause any accidents. They mustn't cause any deaths or injuries. If you never looked into the subject, it's not unreasonable to say that. And as a goal, yes, absolutely. Aircraft are designed to not kill anyone or injure anyone. Nevertheless, this is the real world, and we don't have entire dominion over every causal factor in the real world. So inevitably, there will be accidents. The question is, this is very uncomfortable territory, because you then start talking about whether accidents are, permissible. If you're going to say, well, it's never going to be perfect, but the benefits far outweigh the consequences of not waiting for perfection. Let's say it runs over 100 people a year. Oh, that sounds awful. It sounds even worse when you say which 100 people. Of course, we don't know that. But the kind of reductio ad absurdum answer to this is, in other words, reducing it to its simplest. It's very easy to measure whether these cars are or will become safer than human drivers. And you might even say, well, we don't want them to just be safer, because actually human drivers are pretty bad. They're pretty unreliable. So you might want to say, well, let's have them 10 times safer. I think if you made them as safe or as dangerous, it's not an unreasonable thing to expect it to be 10 times or even 100 times, but probably 10 times or even 5 times. If you were a statistician or an insurance, what do they call them, an actuary, then you're going to say it would be reckless if we didn't insist that people didn't drive if autonomous cars were 5 or 10 times faster.
I was reading that in, I think it was Arizona, they have put legislation in place for autonomous cars in terms of driving infractions. So if your autonomous car, whether it's individually owned or by a company, commits, I don't know, a speeding offence or any kind of, causes any kind of accident, you are liable for that car, even if you're not in it. So, I guess this causes quite a lot of would cause quite a lot of concern for people, because obviously for a technology to work, it needs to be wanted by people and they need to adopt it. And obviously there's a lot of skepticism around it, despite any statistics. So I mean, how is the public trust gained? Rather than just showing them statistics, or people can be told this thing, they've got to really believe that this is something that they actually want. You can't go to the pub, for example. You can't drink and drive because they put legislation in place that says, well, you have to be able to regain control of this car at any time. Then you end up in a situation where people are saying, well, what's the point of me having it? What advantage does it give me?
Habituation. I mean, this is the problem that the airline industry faces, and they constantly have to tell people how safe airliners are. Although that's perhaps not a direct comparison, because there are no alternatives to airliners, practically speaking, to going continental distances in a reasonable amount of time. It's also a problem that the nuclear industry has. My understanding at the moment is that the nuclear industry actually kills less people than some types of fossil fuels, given the emissions that they create. You can quote statistics all day, but as you say, the concern is making people happy with it. And that just has to come from habituation. And every time a driverless car, an AI, or any AI in any scenario makes any big mistake, it will make a headline and people will start to complain about AIs and become cautious about them. There's no way around that. You can do is keep saying, guess what, overall, this is actually safer, but that's not going to be particularly convincing to someone whose sainted aunt has just been run over by an AI-controlled truck.
I think you're right, Phil. The acid test is, and this is quite unrelated to the question as to whether AI-driven cars are safe. What people feel about them is a quite different matter, kind of only tenuously related. And I think if you asked the average person today if they'd get into a driverless car for a 100-mile journey through a city and a motorway, most people would say, actually, no, if there's no driver, I'm not getting in that car. But you're starting to see this change because, Waymo in various cities in the US, Waymo is a very different system to the Tesla. Waymo is far more regimented. It can only drive in certain geographical areas. It has a call center, if you like, where there are people who can take over control of the cars, not drive them entirely, but if they get stuck behind a bollard or something, they can sort out those situations. But yeah, they're taking hundreds of thousands, if not millions of people now who get in these cars with no driver, take them to their destination, drop them off, and then pick up the next passenger. That is working now. Why is Tesla not able to do that yet? Well, Tesla's approach is, you could euphemistically say, it's more ambitious, which is that Waymo's cars have LiDAR, which is like firing a laser beam at objects, measuring the time it takes to return. It's basically laser radar, and it gives you a genuine 3D spatial volumetric model of your surroundings, whereas Teslas rely essentially on vision. They rely on their cameras and incredibly effective AI, a neural net, ultimately, to make decisions. And Tesla, in that light, is incredibly effective because it can drive anywhere. It can drive on roads it's never seen. It can drive on a road that nobody's ever seen.
although the Tesla was the one that couldn't distinguish between a painting and a real road because it relied on.
That's not the full picture, though, because the point is the painting of a real road. How often does that happen, that a motorway is blocked by a giant painting of that motorway?
It's true, but it shows the fallibility of cameras. And, Tesla itself refuses to, has actively dismissed the idea of putting LiDAR on its cars. And
expensive, isn't it? I mean,
it's expensive, but I don't think it's massively so. I mean,
it's a lot less expensive than it was.
Yeah, and surely the best combination would be to have cameras and light.
Yeah, I completely agree. I think Tesla has made a mistake, not least because cameras can get fogged up, they can get mud on them, whereas LiDAR is pretty robust. But I would have thought having an extra layer of spatial volumetric data going into the model, it's going back to this aircraft philosophy of having a voting system on anything that's critical. So you have 3 different types of processor, 3 different programmers have written things in 3 different programming languages. So if one makes a mistake because of a bug or an unexpected circumstance that's never been envisaged before, the others hopefully will vote 2-1 to take that decision. And I honestly think cars should have redundancy in this decision making.
Sure, how much LiDAR is going to help you in some circumstances on the basis that human vision, let's not compare it to other types of AI sensor, human vision only has depth perception out to about 10 meters, 30 feet-ish, give or take. And I would absolutely believe that if you wanted to at night, you could absolutely paint a Roadrunner bridge on the side of a building and have someone drive into it. I mean, that's you could totally do that. So, yeah, I mean, I'm not, maybe it probably would be better than human vision at that point if you made a reasonably long range LiDAR. This all comes down to a sort of general, I mean, I think another problem they've been trying to avoid running over people who are painted on advertising hoardings and things like that. They've been treating that as people. I mean, just anecdotally, I can tell you about a trip we took back from the NAB show in Las Vegas last year to Los Angeles, and we used this at a point where Tesla had its full self-drive enabled for various people at various times. And this thing drove us with full proper real driver monitoring through the thick traffic of Las Vegas from a hotel out onto the freeway. And if we hadn't got bored, it would have happily driven us all the way to LA. Well, actually, it wouldn't have done because we'd run out of power, but it would have done it. And it seemed shockingly good. And it was a stereotypically good driver. But it just comes back to the fact that these things are going to fail in different ways to human beings, and they will fail, and people will get hurt and killed, and that will happen, and there is nothing anyone can do about that. We just have to persuade people that it is better in the long run, and it's always going to be hard to do that when your grandma got run over by one of these things, which is going to happen, and there's nothing anyone can do about that, and nobody will tell you that.
I think Volvo a few years back said that they would take responsibility for any accidents that happen because of their autonomous cars. I think they'd probably refine that to saying if it was shown that there was a mistake in the programming.
One other thing is that I think over here there was drafting legislation for autonomous cars, and I think this idea that you have to be able to take control of the car should it be needed was put in there. This is interesting in itself because some of the concepts for driverless cars don't have any form of control for a human at all. There's no steering wheel, there's no brake paddle or accelerator paddle. Obviously, that makes makes the car much more mechanically simple, which is kind of a good thing. But I think it's going to be interesting going forward, whether that becomes the norm, and then how does that idea of being able to take control of the car fit in there? Do we just have a great big red button on the dashboard that we slam a kill switch?
4 seats facing one another, and even 4 people can have a chat. You don't need any of this other stuff at all. But yeah, I mean, how much of that is us just not being used to it, and how much of that is I mean, also probably we should talk about what vehicles are going to do this, because presumably long distance trucking has got to be I feel the Teamsters coming for my blood at any moment.
I think eventually these autonomous cars will be all interconnected. So they will all know where each other are on the road. And therefore,
important. That is so important. Your mutual awareness, spatio-temporal awareness. So you can imagine, for example, if you've got an autonomous car turning right into a road where there's a building on the corner, so you can't see other traffic, you'd know where all the other traffic is, even if it's through a wall. 5G and more likely 6G wireless connectivity will not just enable this, it is actually being designed around this.
Legislation could be brought into place that legacy manual cars might have to have some sort of system in place that puts them onto the system, so the other autonomous cars know where it is. But just to your point, Phil, about the trucks, I saw that Bill Gates, he was proposing that robots that take over people's jobs should be taxed, and that tax then goes into a universal basic income system.
You would hope. And this is, is it worth stating at this point that what we'd like to end up with is a wonderful Star Trek future where no one has to do anything they don't want to do and everything's done by robots? That this is ideally what we're after. And you can call that, space communism, and it sort of is, but it becomes far less objectionable when you are in a post-scarcity society and everyone can have anything they want and it's not a problem.
Yeah, and I'd love to go into this in more depth because I've thought a lot about it. I mean, it also relates to housing and human rights. And let's do a separate episode on that. But yeah, that's a really, really good point. It's all part of the same picture. It's all going to merge. And when people talk about the metaverse, which is what we'll do an episode on anyway, the point is that the metaverse will, when it arrives, it will not arrive via the pathway that most people expect it will, which is like video games and sort of clunky virtual reality headsets. It will arrive in segments like slices of a pie. And we already have some of those segments. We have our smartphones, we have our computer screens, we have digital signage in public, and every facet of digital information is part of the metaverse, and they will eventually all merge, and then we'll have effectively a digital layer on top of our analog existence. Now, obviously, driverless cars are part of that picture, and eventually they will navigate, of course, through sensors that tell them what's actually going on in the real world, but there will also be a detailed, high-resolution digital twin in real time of the real world, and they will primarily navigate through that, which is the ultimate extrapolation of what we were just saying, where you use 5G or 6G or whatever, so cars can exchange their status. So that's a characteristic of today, the environment we're in, which is that every aspect you look at is ultimately going to end up to be another slice of this interconnected pie, and it will create the full picture. And then arguably you could call that a metaverse.
We'll come to discuss the metaverse in much more detail in another episode. So let's move from computers taking over from humans to computers pretending to be humans. So Dave, you saw today that AI has finally officially passed the Turing Test. Can you tell us a bit more about that?
Yeah. So there's a paper by Cameron R. Jones and Benjamin K. Bergen from the University College of San Diego, and I think it was released today, at least it's been reported for the first time today, where they evaluated multiple systems, LLMs, large language models, plus a human. And the results were essentially the humans doing the interrogating. So if you imagine you had three or four of these large language models lined up, it was a bit like online dating, online speed dating. One of these models was a human model. And it turned out that with ChatGPT 4.5, I'm actually not even sure if that's released yet. The people thought ChatGPT 4.5 was more human than the human.
Imagine being that human.
Yeah. Well, I mean, I wouldn't be surprised if I was the human, but it's obviously a milestone. It's a milestone. Now, Raymond Kurzweil, who wrote The Singularity is Near, and 23 years later, or 20 years later, The Singularity is Nearer, where the singularity is this point where things are progressing so fast that we have no intuitive feel for how quickly that's going. And a possible consequence of that is that AI will have outreached human intelligence, and we'll have ASI, artificial superintelligence. Kurzweil was basically saying that's the Turing test, as originally envisaged, has been totally passed, arguably some time ago, but objectively now. But he's saying a proper, really valid Turing test, named after Alan Turing, is going to have to be a bit stupid compared to an AI model. Because if you say to the average human in the pub, explain to me about polynomial factorization or something like that, the human will say, oh, God, I'm no good at maths. And the AI model will be, sure. And then it'll give you reams and reams and reams of formula and explanations. So, but one thing they did do with all the AI models is they said, behave as much as you can like a human being.
I found it interesting as well. It's probably indicative of how much progress had been made on ChatGPT 4.5, in that I think it had, was it something like a 76% rate of convincing the human that it was human, whereas for ChatGPT 4.0 was only in the low 20%, wasn't it?
Yeah, 4.0 is a different kind of, it's not on the same continuum as like ChatGPT 3.5, 4 and 4.5. It's one of these zero models, which I think is one of the reasoning models. So it does post-inference reasoning. But yeah, it is striking, the differences. And that rate of progress will not just continue, it will accelerate.
Yeah, I think the thing about this is it's really interesting. It's kind of, something of a historical milestone. And it's a historical milestone largely because of the stature of Alan Turing and therefore the fact that people know about his test. One of the things about this is that Turing, when he designed that test or proposed that test, did not know about large language models. One of the things about large language models is that they're very good at superficially appearing to be a human without being anything like what you might call an artificial general intelligence. And this, I was reading an article just today. It was an article all about the Zodiac killer, the serial killer of the 1960s and early 70s in San Francisco, and the attempts to decode some of the cryptograms that were left, which they threw at ChatGPT 4.0. And ChatGPT 4.0 had no idea. It claimed it had an idea, but it had absolutely no idea whatsoever. In the way that AIs sometimes are stupendously confident about not knowing what they're talking about. And it's because it can't do the kind of big logical inference stuff that a human being potentially can. Now, bear in mind that until 2020, no human being had broken that either. So then it took a large non-AI piece of software to finally get it, which they didn't for more than 50 years after it was written. But it serves as an example of what LLMs cannot do. It's almost as if an LLM is something that's almost been designed to pass the Turing test without being the sort of AGI that Turing was thinking of. It's almost like dodging the test. It's perhaps an indictment of the test more than the technology. And this is to take nothing away from the wonderful things it can do. But it's almost like we designed something to pass the Turing test without, in any sense, to pass the letter of the Turing test without passing anything like its spirit.
You're right, but it's not about the model. It's about the emergent ability of the model. And I know you're saying that is specifically something it can't do, but LLMs are always starting to do things that we thought they couldn't do.
Something I'd add to that as well is it's just because something cannot do something, like my dog, can't have a conversation with me with a voice. but my dog is still pretty intelligent. It can learn things, it can learn behaviors, and it can, it responds emotionally to things, so intelligence comes in, different forms.
I guess what I'm proposing is what Turing thought intelligence was and what he was trying to test for with his test.
I think, though, Turing was not fussy about what was taking part in his test. He's basically saying, for anything, this test. And the other thing I say about LLMs is that it's almost like a dawn chorus, that when you start talking about the capabilities of LLMs, people start chirping, oh, all it's really doing is predicting the next word, but it's doing it very, very fast. And that is missing what they're actually doing by many miles.
It's a derogation of what they're really doing.
Yes, it's pointless reductionism. And what you should be looking at is the fact that, you could reduce it to saying it's predicting the next word. But what is the macro effect of it being able to do that at so many simultaneous levels of hierarchy and doing it so quickly? I've used this example before. Saying all it's doing is predicting the next word is a bit like saying all Beethoven and Mozart did was predict the next note.
Well, I think actually you can make an argument about that because they didn't. That's the thing. Beethoven and Mozart picked notes with a much greater and more and deeper understanding of the wider context of what they were trying to do. LLMs are starting to get a larger context volume and all that kind of stuff. They're starting to get more of that, but they still can't even nearly write a novel. The context length for, I think, GPT-4o is 200,000 tokens, depending on what token means for whatever model you're using. Well, that could be entirely wrong. Look it up. But I'll ask ChatGPT. The point is that I think when people say, oh, it's just predicting the next word, which is reductionist and an oversimplification, that's the difference they're trying to make, is that Beethoven didn't pick the next note. He picked the next note with a much greater knowledge of the context.
Yeah, and who's to say that LLMs don't have that as a macro effect of the way they've been trained and their structure and the way the tokens have been embedded in the high-dimensional vector space. So I think what I'm saying basically is don't prejudge these models. Sit back and see what they can do. And they keep surprising us.
What I was going to say is, when you see what they can do, it's really interesting when you suddenly find things they absolutely can't do. And then you start to see the frauds, as it were. You go, okay, yeah, it sounds like a person, but it really isn't.
Yeah. I mean, one example of things they can't do is count the number of letter R's in the word strawberry. It'll confidently say there are two.
It did say two. It said two. ChatGPT just said two. You're absolutely right.
And I went back and I said, okay, look, specifically, how many letters are there in the alphabet? Which letter what number is in the alphabet is the letter R? And it's 19 or something, I don't know. And I said, so can you find out how many examples of the 19th letter of the alphabet there are in the word that is spelt STRAW? And it still got it wrong.
Yeah. See, this is where, that's a much more elegant test than talking about decoding the zodiac ciphers, because that's such a simple question that it just doesn't get.
And yet, if we talk about AIs doing unexpected things, this kind of brings us onto the question of, whether we can truly control AI as it gets more advanced. And I think I did see one article fairly recently that talked about ways of finding out what the AI is actually doing and why it is doing it. And it was effectively described as psychiatry for AI. It was kind of interrogating the AI, trying to find out what it was doing and the reasons why it was doing particular things.
Oh, is this the paper by Anthropic where they had, for example, they had one of their models when it was asked to make a rhyme. And rhyming's pretty difficult because you have to start by finding the two words that rhyme, and then you have to kind of work backwards to find a string of words that will make a meaningful sentence that includes that rhyme. And it turns out that's exactly what it did. So in other words, it didn't take the approach that the old chess playing computers used to do, which is to work out every single combination. They looked at the context, they looked at whether the rhyming word could ever make sense in that context, it kind of gives the impression that it's not just looking for the next word. It's actually, I hesitate to use the word thinking, but it is actually going through a process beyond that. And moreover that, there must have been a meta process to devise that process.
But it's also when you say it's looking for the next word, it's looking for the next word, it's picking a word. And based on what? Not just picking it out of the air, otherwise it wouldn't make sense. So it's clearly making that decision based on something, which is more than just grabbing a word.
But going back to this whole, that thing about it not being able to say how many R's are in the word strawberry, could an AI, given that, it can self-improve code these days, could it understand that problem and improve its own code to be able to do that?
Yeah, I think it will. I think it will be able to, even if it might not do it effectively or reliably at the moment. I think the concept of self-improvement, this is where we leap ahead of exponentiality into hyper-exponentiality, because it doesn't have to wait for us to improve it. It just goes ahead and improves itself. And that point might be one of the biggest inflection points in history. How do we even understand how it does it, why it's doing it, and what it is that's doing it?
All of which are problems you have with people as well. And how do you train a good AI? Well, how do you raise a good person?
Yeah, you do it through education, parenting, and so on. The difference is that we're not all connected to each other via the internet or whatever the internet becomes. So it's arguable when we have robots, capable human robots, if one learns something, they might all learn it.
And, the safety issues of this are not zero. And people laugh about this because it's been depicted in the movies so many times, but, obviously rather enthusiastically. But, there are absolutely legitimate AI safety concerns.
Absolutely. And two AIs together conversing with each other have been shown to, effectively create their own information bubble, as it were, where they're reinforcing each other's ideas and beliefs, I suppose. Obviously, they've done scenarios with wargaming with AIs, and every single time it's ended up in a nuclear Armageddon.
I mean, it is quite scary, because if you think about the sheer amount of computer hardware that's sat out there in render farms around the world, and in server farms around the world, and there are absolutely people watching what's going on. There are network operations centers in which people watch server loads going up and down. Is it plausible that some giant AI conspiracy could get going? I mean, I'm speculating wildly here. Obviously, is it plausible?
I think I believe I believe that's already been tested, and yes, they can.
We're going to look really, really stupid. Like some future of civilization is going to find this planet. They're going to find all of our DVDs of Terminator, and they're going to watch them all and go, "Oh yes!" And like 15 years later or 20 years later, this society was destroyed by its AIs.
We were going to talk about whether we control AI, but I think we need to go into that in much more detail. So we'll do that in a separate episode.
AI safety, safety is the thing.
I think we've covered quite a lot there. And for anyone watching, if you do like what we do, please do like and subscribe, the old self-promotion thing, and share it if you share the podcast if you can. So yeah, we'll leave it there, and we'll come back to some of those other topics at a later date. So thanks, guys.